Hello and welcome to today's WIEF ThinkTALK Series 2021 final edition titled AI and Machines Learning for a Competitive Edge. Now let's welcome our solo performance by WIEF Mocha Fest artist Taslim Jamila. She is a poet, vocalist, and author from United States. Without further ado, please welcome Taslim.
Assalamu alaikum, peace and blessings. The poem is called The Shift. It is about the times that we're living in now and just our ability to be expansive and continue to grow. We are evolving, becoming, renewing, growing from wombs once held prisoner, hostage by our family's memories, now clinging to our spiritual teacher's remedies. Through treacherous times, we remember that heart bonds align, that communities are more than cement structures because they rupture, and mercy and grace has no boundaries of space, but elevates our faith outside of material place. We strive to be like those who are friends of God, who are leveled, legends, loaded, Latif lovers with limitless worth. Some known and unbeknown who walk wondering, pondering, present with us on earth. The Creator's beloved, so breathtakingly bountiful it hurts, who are lively, lit, live and breathe blessings, die before die and give birth, who persevere, prevail, blaze trails, triumph, and first. We are the revolutionary generations that liberate souls with new structures that erupt the complacent codes. The infinite portals of possibilities and plentiful are wide open to provide hope in a new world, a new time, with stretched paradigms and immense light between infinite and infinite lies, endless highs. Now that's the prize. We are exploring, expanding, extensions, growing in lifted dimensions and systems continuously revealing, sometimes strenuous but provoke our own healing. We're the innovators, creating courses yet tread and not afraid to. Who would have known in a pandemic, global gains and growth amplify with a pride pressure? This is for those who live outside the lines, who layer voices made of invigorating visions, imagine beyond the grind. We create the immense essence of fresh discoveries with fluid tongues. We incite change and leave the curious numb. We replicate the genius factor and rearrange the cellular patterns to become. Our spaceless activity activates the intelligence of cosmic being from dimensions inside gateways that hydrate amaze. We're brilliant souls, racing to technological timelines, bringing them to boardrooms outside the guidelines, on God's speed beyond galaxies, where we reimagine with compassion, without distraction, to fly. We had to listen to the hawk, true reality, and our heartbeats. As the world heats to cool viruses and sends a message that even baffles the scientists. It said, attention, we interrupt all these nations with mediocre stations, playing and rewinding outdated applications. We sat under moonlight with Saturn glowing for inspiration, with zikr chants and Quran recitations vibrations. New workstations emerged as we augment new narrations. As infections erupt and corrupt molecular systems, destroying data, we are creating theta waves for greater days during focused sessions. The progression is plummeting as limitless learning formulates renewed expressions. It's new language, hacked and translated, a sign of what our souls have waited. We are evolving, becoming, renewing, growing from wombs once held prisoner, hostage by our families' memories, now clinging to our spiritual teachers' remedies. We are remembering that before the scars, we are souls reflecting the essence, supreme, superb, flying toward our magnificent manifesting of existing. At this very moment, the power is shifting to live, to be, to create new nourishment now. Thank you. Peace and blessings. Salam alaikum.
Thank you, Taslim, for that wonderful performance. Now, up next for the highlight of the day, let's welcome Nazri Muhd, founder and Group CEO, MyFinB Group Singapore. Now, Nazri Muhd is the founder of MyFinB, Center of AI Innovation Global, chairman for the AI World Summit, and also serve as the Honorary Counsel of Cape Verde, West Africa. He specializes in AI and cognitive analytics with more than 2 decades as a practitioner in these fields. As an early pioneer to deploy AI-based analytics in Asia Pacific since early 2000, Nazri leads the digital transformation strategies for public, private, and non-profit organizations globally, where he serves as their AI advisor. Now, through these roles, he has successfully built a strong global community of AI adopters and practitioners in more than 50 countries. Now, the floor is all yours, Nazri.
Thank you very much, Ina. We are very privileged here to welcome a very distinguished speaker by the name of Dr. Waleed. He needs no further introduction except the fact that he actually came from Google, from Uber. He's the data scientist, computer engineer, and whatnot. He has a list of achievements that has up on his sleeves. At the same time, he is also the head of engineering at Anyscale from the United States, the company behind the open source distributed machine learning project Ray. Prior to Anyscale, as I mentioned, he was at Uber, and prior to that, he was at Google. So he will share with us a very insightful presentation, and I will moderate it, and I will connect the dots together and try to put it into context for your perspectives. Yeah. So without much further ado, let's welcome Dr. Waleed and his presentation. Thank you so much.
Thank you so much, Brother Nazri, and thank you to the World Islamic Economic Forum for inviting me. Thank you very much, all of you, for attending. I can't wait to talk with you, hear your questions, and just understand what's on your mind with respect to AI and ML. So our plan today is really what I'm going to do is just give a quick introduction, like literally one slide of AI and ML. I'm going to discuss why is ML happening now? Like, these technologies have been around for a while. What are the combination of things that have led to it? From my own experience, I will give a few examples of it being used as a competitive edge, and then some practical tips that I've learned from doing many machine learning projects in a corporate context. And thank you so much for your questions, and please don't hesitate to ask questions. So to just give a quick make sure that we're all on the same page, let's make sure that we have the same definitions. So AI is really about computers that try to simulate things that we usually think of as human and not computer-like. Natural language, speech, understanding images, all of those types of things are things that historically computers haven't been able to do. Within AI, there's a subfield of called machine learning. And machine learning, what really distinguishes it is that you can use examples to train the systems. So old-fashioned computer programs, there'd be a programmer and they would carefully write a program to execute something. With machine learning, we don't need that anymore. You just give us examples of the right thing to do, and these systems learn it. Now, within machine learning, there's a particular style of machine learning called deep learning, which is all the current rage. This is really a set of approaches to machine learning that use something loosely modeled on biological neurons. And this technology is the one that's really helped machine learning take a quantum leap. So the question is, why now? I mean, we've had these technologies for a long time. Why is it that they're exploding now? Why is it that now is the right time to invest in AI? And there's really 3 reasons. The first reason is that ML is really about examples. And the more examples, millions, billions, or trillions of examples, the better these systems perform. And effectively now, we have infinite data on the internet. For example, if you want video, there are 30,000 hours of video uploaded every single hour on YouTube. So that's as close to infinity as you can get. And right now, many of the companies that you folks work at are starting to build data warehouses that have that huge amount of data for your particular domains, for the particular problems that you folks are trying to solve. The second reason is that the algorithms have gotten better. So these three charts show different domains. This one shows image recognition. So is this a picture of a cat or a dog? This one shows speech recognition, and this one shows chess. And the amazing thing is computers can now outperform humans on many of these tasks. So on chess, they're well beyond humans. If you look at chess, it's close to 3,300 ranking. And then on recognizing images, the newer algorithms are doing even better than humans. And in just about every game that you can imagine, computers are outperforming humans now, even on ones that were traditionally thought to be difficult, like Go. And then the third reason for why it's happening now is computational power. Historically, we have used things called CPUs for doing machine learning, but in the last maybe 5 to 10 years, what's happened is the graphics cards in computers that were originally intended for games allowed for a massive boost in performance. That type of power, it just happens that what you use for rendering 3D is also very useful for doing machine learning. And so for that reason, it's really accelerated the process. And that means that you can now process many, many millions of more images. So coming back to our topic, can AI and ML provide a competitive edge? The answer appears to be yes. And I will give some examples of that in the coming minutes. But when surveyed by McKinsey, 84% of companies identified the competitive edge that comes from AI as the main motivator for why they would do this. So clearly, even if we're not confident that it's a competitive edge, the industry as a whole and multiple industries are now recognizing that AI is the key to a competitive advantage. And those who don't make that migration to AI, there's some concern that they'll be left behind and not be able to compete. So all of that sounds good, but what are the ways, what are the different, to help understand how AI and machine learning can help? What types of tools can we think of, or what types of problems can we think of that it can help with? And the answer to that is, the easiest way that I think about it is to think about things in three categories. The first one is automation. Imagine things that used to be done by humans, very tedious things, and now all of a sudden you can use computers to do them. So think about booking an airline flight, or automatically processing data, or rather than looking at hundreds of thousands of pages of legal documents, have a computer that can go through and say, these are the types of things that I'm looking for, and it will do the search for you. The second one is optimization. So imagine that you have some type of optimization problem like supply chain, or you're trying to work in manufacturing and you're trying to optimize it. AI and machine learning can be used to enhance your performance and to make your performance more effective. And then the final use case that I think is very powerful is prediction. So many of the times, you're trying to forecast something, trying to understand what's going to happen to it. And this is something that machine learning is very good at. And that can be in time series or markets, or lots of other things. Also in people's preferences. So for example, many websites that you go to now have that page where they go, well, people who bought this product also bought this product. And all of that technology is built on machine learning. Another example of prediction is lifetime value. When you're making decisions about a customer, you want to estimate how much money, how much revenue they will be able to generate for you. And you can build systems that estimate lifetime value very effectively using machine learning. So I'm going to give a few examples now, just three. And if someone asks nicely, I have a fourth. These are from my personal experience. The thing is, there are so many applications of machine learning now that any subsample is just going to be inadequate. I'm going to spend a few minutes on this presentation, but I could easily spend 10 hours of just different examples of problems people have tackled with machine learning. So if you want to learn more about your industry or your favorite domain, I may know something about machine learning applied there. And machine learning is still at the stage where it's very field specific. It's not a generic technology. And so for that reason, each different problem has a different set of properties. So let's dive into 3 examples that I've worked on in the last few years. So this is an example. Remember, I said before, there's automation, prediction, and optimization. And this is an example of quite literally a competitive edge. For those of you who don't know, America's Cup is like the amount of money spent on the America's Cup is ridiculous, and some would say obscene. Tens of billions of dollars on a boat race. But it's one of the oldest trophies in the world at 160 years old. And so people pull a lot of this money into this. So in this particular problem, what happened is one of the teams hired McKinsey to help them design the best boat. And they built an ocean simulator. And then what they did is that they optimized 2 things. Number 1, a boat designer, and number 1, a sailor. And actually, you can play these 2 things off each other. So a better boat designer designs a better boat, and then the sailor, sails that boat better. And you can just iterate and just use machine learning trained on lots of examples of different conditions to create a very strong design of the boat. And you can also, believe it or not, the AIs created with this approach were teaching the humans better ways to sail. And of course, my company is Anyscale. This is a very complex problem, so they actually tested their system. They trained their system using Ray, which is the software product that we produce. Here's another example from my experience, and this one is in the spirit of automation. And this is a very small startup, very early stage, called Retrocausal. And I'm an investor, and I'm one of their advisors. But here's an example of what they did. They built a computer vision system. So imagine that someone is building building something, and they need to put a bolt in a particular space. Could you use a camera looking at them building it to identify when they make a mistake? And they've actually built this, deployed it at NASA, have lots of customers, and have actually started to evaluate this kind of using AI to monitor workers to catch mistakes earlier so that you don't have to rework later. And what that means is the yields for the first versions of products are up 10%. Assembly issues have been reduced by 60%. And operator time now, because you have this system that can catch mistakes, is reduced by 44%. So this is a great example of an application of machine learning that enables very clear, very crisp a competitive edge. If you're increasing your yields by 10%, you can imagine that 2 competitors, one that uses this and one that doesn't, their outcomes can be very, very different. And then another example of automation is how we used AI and machine learning at Uber to help improve safety. So, for example, this wasn't just one algorithm. This was a suite of different machine learning applications. So the first one is sometimes drivers pretend to be other drivers on Uber because because they want to borrow their account or whatever. And so it's very important for us from a safety perspective that we know who's driving. So we used AI and machine learning to make sure that the face matches the photo on file. We can detect whether drivers or passengers are wearing masks or not by using the phone to recognize the mask. And we also did a lot of really interesting work on using the sensors in the phone to detect when an accident can happen. So there are sensors in your phone called accelerometers that measure the forces on your phone. And what can happen is if we feel like a big hit, a big collision, we can then pop up a questionnaire that says, hey, were you involved in a crash? Is this an emergency? Using AI and machine learning. And then the final example of how we used machine learning at Uber is to predict future demand. So you can imagine that, we have a lot of data about, when do people need vehicles with Uber? And sure enough, we can actually build systems that predict that very accurately. And that allows us to tell, for example, drivers, hey, if you go to this area, there will be more demand. And it allows us to choose prices that help to balance the market. So by studying the examples and the data of previous days' demand and the history of demand, we can build very accurate estimates of future demand. So now that we've gone through a few examples, what I'd like to leave you folks with is kind of a little bit of a toolkit to help you go out and try to find machine learning problems that you think might be a good fit. So really, to make a successful machine learning system, the first thing you need is examples. And examples of the data that are there images of the things that are correct and incorrect. The more examples that you have, the better. Maybe you don't have labeled examples that say this one is a whatever. And there are systems now that allow you to label data. Ideally, you're not starting from scratch. So if you're starting to work with language or images or those types of things, there's already lots of very strong existing tools that are out there. If you're starting with a new problem domain that someone hasn't applied machine learning to before, then it becomes more of a research project and less of an execution project. The third thing is that you need to know when you're doing a good job or not, because people tune machine learning models to get maximum performance out of them. And if you can't tell a good model from a bad model, you're not going to be able to deliver value. And then ideally, what you want is some connection between the machine learning that you model that you build and ROI. And that can be either top line. So for example, you could use algorithms for sales leads that increase your revenue, or bottom line. You could use machine learning to help make your business more efficient by, for example, handling customer support calls more efficiently. Those are the easiest, but there are lots of other ones that you can imagine. But the idea here is you have some kind of metric to say if you've done a good job or not. So that's kind of like the character of this. But often in the modern business world, one of the challenges you faced is essentially the question of build, buy, or partner, right? And that's also true in machine learning. So let's talk about 3 different models of success with machine learning. So the first is to build your own data science and machine learning team. And that has a few advantages because they can get to know the business, understand it. And if you believe that AI is a competitive edge, that's something that you don't want to have a dependency on an outside company. A second option is consulting. So this is where you hire consultants who have expertise in machine learning. They come, they build the system for you, and then they go back to their regular day jobs and consult for other people. But there are problems with that too, right? Like you have the knowledge retention problem, you have the maintenance problem. What do you do when the system stops working? How do you make sure it doesn't gently degrade? And then this is really the exciting thing. This last one is the very exciting things. It used to be that if you wanted to apply machine learning, doing every problem was basically starting from scratch. But what we've actually seen is that now people are building specialized software as a service, machine learning as a service models. And those solutions are getting very specialized now. So one example that, like just to give you an idea of how specialized the machine learning is these days, there's a company called Tractable.ai. And all that they do is they estimate the cost of repairs after a car accident for insurance companies from photos. That company is now valued at $1 billion, right? And this is really starting to kind of become a very much, it's the number of startups that I see that are ML for ... where ... is whatever you want it to be, are very large. But there are some downsides as well, right? Like one that's, you may have slightly different preferences from the other people in the market. And then the other one you have to pay attention to is how comfortable are you with the examples that you provide being used to improve models for other companies that might be competitors. So these are the different options you have for how to implement this, and you might want to consider which of these you go for. And you might also want to give some thought to like, how do you want to introduce this? And it's just like any other tool or any other technology. And the idea here is to build a portfolio of internal success stories of applications of machine learning. So ideally you pick the first problem and it has the characteristics that we talked about. There's a very clear ROI. There's lots of examples available. Ideally, it's a well-trodden path. And this is one is very important, right? Like, not everybody is excited about ML, right? For example, if you're going to replace lots of people with an ML technology, which sometimes does, is one way to affect costs, that team may not be excited. But let's say there's a sales team, in the company, and they see the power of machine learning for improving sales, they might be very excited about the technology, and that increases the chance of success. And the idea here is you build this portfolio, adding one project at a time, time over time, to help do that. So finally, there's a few things that you need to pay attention to. ML is not free of moral and ethical questions. I think there's a few things that you want to think about. One is privacy, in terms of sometimes if you're not careful, your machine learning model can leak data. And I can give you a very fun story of something that happened on that front recently. You want to be sure that if you're not careful, machine learning can introduce bias and fairness issues. So for example, when Apple first released its credit card, they used a machine learning model to decide who should get a loan. And unfortunately, if you were a woman, your chances were much lower of this actually happening. And so somehow they had built into their machine learning model a gender bias, right? You also have to consider is what happens when the machine learning gets it wrong. They're not perfectly accurate systems. And then finally, what you learn today and build a model on today is not going to be the same as the model for tomorrow. And there are some domains where you have to be very dynamic. Like if you're using machine learning for fraud detection, you're updating your model every day because you have people who are trying to break your machine learning. So just to kind of summarize, across multiple fields, machine learning, especially in the last decade, has really taken off. What I hope that you might have taken away from this is starting to identify problems that have the right shape for application of machine learning, labeled data, good metrics for success. And as you try to implement these systems, here are a few things to think about. Privacy, fairness, an escape hatch when the machine learning inevitably gets it wrong, and how do you keep your models up to date? And if you have any, I'm really excited to take your questions and just see what's on your mind. But if you have questions or thoughtbacks or anything later, please just drop me an email at mwk@anyscale.com. It's been a pleasure talking to you today. I'm really looking forward to your questions. And I'll stop sharing now.
Thank you so much, Dr. Waleed, for the succinct and insightful sharing of your knowledge. I can imagine all your decades of experience being condensed into a 10-15 minute session would be an extreme challenge for you. But nonetheless, I'm very, very sure the audience have gotten a few key points, the salient ones especially from you. If I am allowed to recap some of the things that you mentioned, you talked about the examples of how AI and ML are being applied, such as the automation part, the optimization part, and the prediction part. Essentially, what Dr. Waleed is trying to say is AI and ML have the strong ability to teach humans better way of doing things, right? And in this case, you talk about catching mistakes early, you're talking about increasing yields, you talk about safety standards and precautions from the perspective of Uber drivers and passengers. I thought these were very relatable examples. We have several questions coming up, but before that, the last part of your presentation talks about the accuracy. Right, the accuracy where you say that the AI ML is not free from any errors, right? So in this case, allow me to pull out one question from the member of the audience, from a guy called AI Chan. Not sure whether it's his acronym or whether it's his real name. Yeah, what is the percentage probability of failure of future prediction? Maybe you can start off with that.
Okay, so it really depends on the domain. In some domains, you can get highly accurate predictions. In other domains, like, for example, the finance market, if you can predict whether the stock market can go up and down with 50.7% accuracy, you have a profitable system, right? So in that particular domain, it would be amazing if you could get 50.7% accuracy. In other domains, like, say, speech recognition, you can get 97, 98%, 99% accuracy. So there's no way to answer this for all problems.
And how about healthcare? Like, for example, what kind of percentage rate would you deem as acceptable in a healthcare setting?
Yeah, it really depends, but the best solutions that I found are the ones that combine human expertise with professional review. So it's almost like the human and the machine are working together. So, but again, which problem are you talking about? Are you talking about detecting cancers? Or are you talking about estimating life expectancy or other more complex problems?
Right, and we have more questions. Thank you for that. We have more questions coming in. If you can look at your Q&A chat box there. Yeah. A question by Raymond Rasfuldi, who asks, can we take the same approach from general AI ML development to physics-based problems in engineering and industrial production? So is there a common general framework that can be applied into engineering and industrial-based settings? I think that's what he's after. Or you need to do a lot of customization for that.
It depends. If it's for a domain like robotics, there are very well established simulations, and this is one particular area where there's a particular flavor of machine learning called reinforcement learning that's being done. And so if you're looking to simulate physics-based systems and optimize so one of their favorite problems is optimizing walking gaits. Can you train someone to walk very efficiently? And so yes, in some domains they do have this, but if it's it's been applied to chip design, it's been applied to chemistry. There's lots of applications of machine learning to physics-based systems. And in some cases, like one example, thinking about optimization, that's on the edge between chemistry and physics is protein folding. How will a particular protein shape itself so that it can, how suitable is it for an application? And Google just released, for example, one of the best algorithms for estimating protein folding in the world yesterday.
Linking the question given by Raymond to Jonathan, still in the industrial stroke manufacturing setting, how long would it take for a typical AI ML framework or model to take place? How long does it take to do the training in a typical manufacturing process? And how do you define a wrong versus right? I guess some of this can be pulled out from your slides earlier, but if you can elaborate a little bit more on that, that'd be great.
Yes. So in that particular case, thinking about the company Retrocausal, the entirety of their innovation is in how few examples it takes. So historically, to do something like you missed a part, it would take, 50, 100, 200 examples. The essence of their technology is they've taken it down to 5 or 6 examples. And there's a particular type of machine learning called one-shot or few-shot learning that is all about how you can train systems with very few examples if it's in a domain that's well understood, like computer vision. So this is a very active area of research, and people are trying very hard to minimize the number of examples that you need.
Thank you so much. And the questions go on and on. Specifically on ML applications, I linked 2 questions together from Abu Bakar and AI Chan again. The applications of ML for small businesses as well as ML being used for blockchain technology to minimize hacking and virus. Could you combine the 2 questions together in the context of ML being applied for small businesses, whether it's suitable and under what circumstances would it be suitable? Followed by another question, okay, if this is being applied onto a blockchain technology for the purpose of anti-hacking, for the purpose of antivirus attacks with backup on cloud, what are your thoughts on that from a practitioner standpoint? Over to you. Thank you, Doctor.
Yeah, so on the small businesses side, we talked about in-house consulting and pre-existing specialized solutions. In that particular case, I would bias towards pre-existing specialized solutions. So for example, you have a web presence, right? And you can go to Shopify and you can ask Shopify to use machine learning to suggest additional products, right? So in many cases, the products that you already use for the execution of your small business are using machine learning, right? A very popular thing for small businesses is robotic process automation. Can you take something like a sequence of steps that you do for every customer on your computer and automate it, right? So there are off-the-shelf tools you can use for machine learning in small business contexts, and the people have done the work for you, right? And now it's not going to be as advanced as if someone comes and does a custom solution, but you can definitely get your foot in the door that way and build on it. As for using blockchain technology, generally the perception in the industry is that we thought blockchain would be used for everything by now, but really what we're finding is many of the problems that people thought needed blockchain can be solved without blockchain. And the other problem with blockchain is that it's not very efficient. You can't store that much because you have to everyone has to agree on everything. You have to send lots of copies of the data around. So it's not always well suited for this data. Having said that, there is a startup based out of the University of Berkeley that's exploring the use of blockchain for privacy data of the kind that's used in machine learning. And there are, it's just like anything else. There's actually an entire field called K-anonymity that is all about how do you build machine learning models without sacrificing people's privacy.
Okay, let me link 2 questions together from small businesses to blockchain. And now the applications of AI and ML for the Telecom Regulator. side of things. So if you're a telecom regulator, telco regulator, how can you use AI and ML for the benefit of industry and people? Any use cases that you can share there from Harry Halib? And then from there on, the next thing linked to the applications and usage of AI is how can you use ML to judge or evaluate a person whether he or she is guilty or doing something. So if you can share with us two things from a technical standpoint as well as from a use case standpoint. Now, technically, is it possible? And if it is, where and how is it being applied out there in the market? I mean, you cited a few examples which are pretty excellent for us to check out further, right? So how would you link these two questions to the earlier questions that you answered?
Yeah, so I wish I knew more about the telecom regulation industry and what it involves. And it really depends on the country, right? So one thing I would think about is optimization problems, right? How can we get multiple regulated companies to work together more effectively? And the other ones that I would think about is there a monitoring application here? How can we determine when something is unusual with one of the people that we're trying to regulate? And that's how it links to the next one about, using ML to judge a person is guilty or not. Judging someone's, this is a very, very complex area, right? Ethically as well as technically, right? And I think sometimes we trust machines more than we should. As someone who builds the algorithms myself, I don't trust machines as much as I think members of the public do, right? I have the technical understanding to know that I shouldn't really trust algorithms, right? And especially for something as important as this, whether someone is guilty or innocent, trusting a computer on this is like, honestly, a pretty bad idea. Having said that, using computers as a forensic tool for certain types of activity, criminal activity, for example, money laundering or fraud, is very, very common, very, very established, right? Like at Uber, people would try to rip us off every 5 minutes, right? So you can imagine in that context, using machine learning to at least become suspicious. Is this driver a real driver or not? Should we investigate this person? Is something that makes sense depending on the terms of service and the understanding between you and your customers.
Thank you so much, Dr. Waleed, for your candid responses from somebody who created algorithms and put some caveat to it. I think that's pretty honest and very, very upright, to admit up front. But of course, there are certain benefits, from using it from a data point of view. So at least some form of data is better than no data. And in relation to a particular question, for those adopters of AI who's considering to deploy that in developing countries like Africa, what sort of difficulties, challenges, and opportunities that exist for countries like in Africa, for example? Of course, the Africa itself, you can't generalize, right? Some nations in Africa would have been more developed than the other. But how would you address the issue of adoption and implementing AI with I'm not sure whether it's got serious or serious tech issues, but with some infrastructure or mindset problems or challenges there. What are your thoughts on that?
Yeah, so in some ways, being late to the party is sometimes an advantage, and we see that, for example, in Africa, we skipped basically the wired internet and skipped straight to mobile, right? Given that that's the case, you customize the application of machine learning to what works, right? So, for example, one thing is many people think that machine learning is only on the cloud, but a lot of machine learning applications are on your phone. So what you do is you do offline machine learning that runs on the phone, and it really depends what the person's trying to accomplish. It might be, for example, that a farmer might use image recognition to identify a particular pest that's on their food. Pest that's on the farm, the crop that they're holding, right? That you can make in such a way that you just download the model on your phone. No matter how crappy the internet is, it just runs locally on the phone, and they go, "Oh, that's this type of thing." You don't even need particularly high-end phones for things that are not real time, right? So you can take an image, the phone will get it hot for like 20 seconds, and then it will give you the recognition result, right? So I think one of the great things about machine learning is that it's very adaptable. And you can usually do things like trade resources for accuracy. So, let's say that I have what's called a model. A model represents what the machine learning system has learned. I can sometimes cut its size by 90%, for a 2% reduction in accuracy so that it can run on someone's phone. That's the type of trade-offs that you make when you're in that kind of environment. For really innovative issues, one of the big challenges with machine learning right now is just how much computational power it takes. And that computational power is unlikely to be available in a developing country. And so that's the challenge for like doing really cutting edge machine learning. But how far you can get with like just a laptop these days is kind of amazing compared to where we were 10 years ago.
Thank you, Dr. Waleed. There's a question relates to the performance aspects of it. So do you think quantum computing could help AI in certain aspects, such as the performance? I would assume this relates to the performance of the systems and the output that is being generated from Devendran Marimuthu.
Yep. The answer is it can be used for computing, quantum. In fact, so there's a company called D-Wave that's one of the most advanced companies that has a very special type of quantum computing that's very well suited to machine learning. It's especially for those optimization problems that I talked about earlier, they map very well into quantum computers. Having said that, quantum computing is like a 10-year, 15-year technology thing, right? I don't think, I don't think people have worked out the algorithms to take full advantage of quantum computers. So I think the applications will be niche, and it's amazing how far you can get with very simple approaches.
Just an add on to that question, which region do you think is getting the lead in terms of quantum computing? US, Europe, or China, or India?
Yeah.
Which of these four countries do you think are leading the race towards quantum computing? Any thoughts on that?
I wish I've been tracking it, but I don't feel like I'm expert enough to give that the answer on that. Some of the public information suggests the US. So Google, for example, claims that it has achieved what's called quantum supremacy. In one particular example, I read their research and was like, yeah, that's not really a very strong case to make. So it's very hard to know. But some people would say the United States, but it's not obvious who's in the lead.
Okay, thank you so much for that. Getting back to the use cases and applications of AI, this seems to be the trend of questions happening here in the Q&A chat box. Yeah, two sort of questions relating to the use case. One, chatbot in banking industry. The other one would be the recruitment process of candidates in a HR setting. So how would you explain the technical and the applications of AI ML through the use of chatbot and through the for purposes of recruitment process in a HR setting? Over to you.
Yep. So this particular chatbot application talks about a rule-based approach. So a rule-based approach is a manual approach, and then move to what's called NLP, which is short for natural language processing, and then the end state is AI. That's a very, very logical progression. And the main reason it's a very logical progression is because it allows you to collect data to use to train your machine learning. So you start with a rules-based thing, you get the logs of what people try to do. You can now use that data to train a machine learning model. So that's a great recipe for how to do this. And you have your foot in the door. And this is pretty much the standard way now for doing things. But there's a lot of energy in this space. There's a huge amount of energy going into this space. And a lot of off-the-shelf things you can do. So there's definitely off-the-shelf chatbots you can get. There's probably off-the-shelf chatbots particularly designed for banking that you can get. That's how specialized things are getting right now. And to answer the question about AI in recruitment process, there are now technologies that are using AI to kind of look at lots of resumes and highlight the ones that might be well suited to you. There are also systems that well, one concern with that is that those systems can show the type of bias that I was talking about earlier. So they may be biased against people, women. They may be biased against people who have too many degrees, because you don't always know. One of the big problems with machine learning is that it's sometimes a black box. You don't exactly understand what the machine learning model is doing. There's a new field of machine learning called explainable AI, to actually just try to understand what the machine learning is actually doing. So there's some delicacy there in terms of how you use it for things like recruiting. And you need to make sure that, especially since in many companies, diversity is a very high priority, that you don't introduce those biases. Now, having said that, you can actually turn the problem on its head and use it to identify candidates who present an opportunity from a diversity perspective. And you can kind of take it on this way.
Thank you, Dr. Waleed. You've just mentioned about the bias stroke ethical aspects of AI. Earlier on, you talked about the applications and the use cases of AI. Now, how about a question by, again, Tevendran, from a job displacement versus job replacement point of view? It's a very popular question that always exists in every AI-based webinars or workshops. So what are your thoughts between job displacement versus job replacement? Perhaps you can start off by differentiating between the two, and where are you gravitating towards when it comes to adopting and the impact of AI adoption?
Yeah, so there are different perspectives on this, and the jury is out. Nobody really knows. My own personal opinion is, if you're worried about AI taking over the world, that's crazy. One of the top practitioners in the field is a person called Andrew Ng, and he says, arguing about AI taking over the world is like arguing about real estate prices on Mars. It just, we are so far away from that it's not really relevant. So I'm less concerned about, but there are challenges. I mean, I mentioned automation. Automation is the act of replacing a human with a machine. You can't pretend that that's not the case. But what you can do is think about where I really wish things are going, and I wish it was under my control. And this is where politics and technology intersect, and not in an easy way, right? Where I wish things were going is we start to see AI as an augmentative technology. And we're starting to see this now. So even people writing, like movie scripts and stuff, they now have AI assistants that help suggest ideas to them, right? Music, people who put together music are using AI to help them put together different types of music. That's where I hope it will go, right? This question for society is really the question of, the way I think about it is, AI is going to introduce a surplus, right? In the sense that AI will make things that used to be very hard, much cheaper. And societies are now responsible for deciding what to do with the redistribution of that wealth, right? So imagine that things that used to be very expensive or hard to do are getting cheaper. And the concern is, how do we ensure a fair distribution of the benefits of AI across society? And unfortunately, I fear in many capitalist countries that the AI surplus will accrue to the rich and accrue to the people that already have wealth, right? But if we can design things in such a way that everyone benefits from the surplus in efficiency from AI, I think we can look at smart ways to do that. And I know it sounds crazy, but this is, for me, AI is one mechanism that would enable, in some cases, a universal basic income. Because it just, like, even farming becomes more efficient because of AI. Distribution, supply chain becomes more efficient than AI. Just everything becomes more efficient, and that efficiency goes somewhere. The problem is, I believe in modern societies, a lot of it is going to go to the people who already have a lot of things. Let's take steps as a group, especially as Muslims who care a lot about social justice and social welfare, to kind of address that particular issue and campaign for even distribution of the AI surplus.
Thank you, Dr. Waleed. Just a little bit of a reminder to everyone to post their questions ASAP. We have about 10 to 15 minutes more to go. And it's not easy to get Dr. Waleed's time, and kudos to the organizer for getting him to agree and share with us his perspectives and his knowledge in AI and ML. So I would urge the members of the audience to post their questions, and we can take on a few more before we adjourn and pass over to the host. Okay, so my quick question to you, leading to the part about the social justice and social finance part, right, of the Islamic economy. How well do you think the AI and ML that have been deployed within the Islamic economy itself? So you have the world economy, right? So within the Islamic economy, within the social finance of Islamic economy, to what extent do you think AI and ML models have been successfully deployed, and how far away are we from the conventional markets? Yeah, what's your honest and candid observations on that?
Yeah, so I wish I knew a lot more about the Islamic economics, especially where they've been created. And my understanding is, again, for many Islamic economic problems, you can just use the typical off-the-shelf solutions. But I would, one of the things, from an Islamic perspective that I really like is that there are mechanisms built into the Islamic system that redistribute wealth. The prohibition of interest, the zakat mechanisms, and so on. And so, I don't think we fully optimized using machine learning within an Islamic framework, but it might be that I just don't know. And maybe there are people doing some very awesome stuff. I mentioned earlier that I had a fourth example of an application of AI and machine learning. And I was thinking about the verse from the Quran that says, that the believers compete in doing good deeds. And maybe that was an area for competition. And there's a great website called Tarteel, TARTEEL.ai. And they use machine learning and AI to help you memorize Quran. It listens to you and it tells you when you've made a mistake. It fills it in when you pause, right? So this for me is like a great example. And I know it's not, usually we think about competition in mundane and material things, but even in our religious practice, AI and ML can help us do a better job and compete in doing good deeds. I'm fortunate enough to be on the board of Tarteel.ai, but it's a really good group of Muslims who have worked on this and built some pretty cool technology.
So do you think that we are underrepresented in many sectors within the Islamic economy as far as AI and ML is being deployed? Are we far away? How many years or how many years ahead or behind are we when it comes to that particular technology being deployed in the Islamic economy overall? Just a rough gauge. Because you've seen both sides,
Yeah.
right? You've seen the Islamic, you've seen the conventional side. Do you wish there's more to be done? Do you wish that we hit a certain milestone within the Islamic economy?
Mm-hmm. I think there's a long way for us to go. I think, we're still, we're still dealing with basic problems of, getting the systems up and running in many cases. You need to focus on that before you can apply AI. So, for example, I talked about the importance of having clean data to use to construct AI models. In many Islamic situations, we don't even have the clean data to potentially use to train machine learning models on. The irony is that if you actually work in Silicon Valley, many of the founders, many of the top people in the field are Muslims. I know several founders of very successful startups, one in the supply chain optimization space, that's kind of one of the things, that are Muslims. I have many colleagues who are Muslim. So it's certainly not a lack of talent. It's or intellect, right? Many of the publications. I'm very fortunate to work at Anyscale with someone who's a Palestinian, who is like one of the best members of the team, right? And he's gone through a lot of hardship to get to that place. But we have the talent, we have the skills. It's just really the logistics and challenges of organizing effort that are ahead of us. It's not the intellectual exercise. And, frankly, machine learning is built with pretty standard components, right? It's a graphics card and a CPU, and it's not that hard for us to set it up. And the expertise exists. So I don't know enough to really judge, but I do know that if we are far behind, we can do a lot more to catch up.
Thank you, Dr. Waleed. Don't mean to ask you to give us a model answer of a yes, no, but certainly your views are very important for us to understand the state of affair, the current landscape that we are operating in right now. Question by Shazvina. Again, politically or not, we need your views on what makes China to imply innovate things with AI more than any other countries. Why are they having that lead, or seemingly to have that lead over any other countries? In fact, a PwC report once said that they're going to overtake the US, right, very soon, not just in terms of economy, but in terms of AI deployment and all that. So do you agree with this statement or not? If so, whichever it is, do explain and give us your thoughts. And the second part of her question, Shazvina's question, is what is it that universities need to do to teach AI and ML better, in terms of their industry relevance to the students? So perhaps you can tackle this question first. Thank you.
So certainly in the field, so Anyscale has partners in China, and they move just as fast as us, and they have people just as smart as us. And they have, the people that they have, again, in some ways, machine learning is not very capital intensive. Like, you need computers, but you need computers anyway, right? So machine learning is one of those areas where brains can make a big difference, right? And what China has a lot of is very smart people who can think through problems and apply technology, right? They do have the largest population in the world, obviously, and they've invested a lot in education and technology development. In some ways, and I think about the Japanese model, there are certain situations where the centralized organization model works better. And what I'm seeing is that in some ways the level of investment in China is greater. But I'm still seeing that most of the innovation, the clever algorithms, the things that push through are coming from Western countries to some extent. But then the Chinese are matching, right? So, for example, there's a very famous system for doing text called GPT-3. And it was well known because it used 180 billion parameters, right? And this at the time was the greatest thing, right? And then what happened is that a team in China took the exactly same design and then built a model with 100 times as many parameters, 18 trillion parameters.
Wow.
That was even more accurate, right? So there's a lot of one-upmanship. I would say that some of the more innovative ideas seem to be coming from the West, but I'm not sure how long that is. And again, just like I said, you know, if you work in Silicon Valley, you find that there are lots of Muslims. If you work in Silicon Valley, there are also a lot of people from China. And again, you know, they're people who work alongside me. I love working with them. I've learned a lot from them. Yeah, it's a great experience. I mean, one of the best things about, you know, working in Silicon Valley is that diversity of experiences.
Thank you so much. Very, very good answers there. I hope what's her name? Sorry, I clicked done already. The lady has gotten the answer that she wants. Excellent answer, Doctor. Okay, we have a next question. Very interesting question. You've spoken about explainable AI earlier on. Then now let's come up with a new term for it, traceable AI. Okay, so whereby a question by Usman Gana Muhammad. He is asking about how do we delete, right, traces of our data using AI, where a set of copies would have existed in certain place, but somehow, even if you deleted that, we may have existed somewhere in cloud or somewhere in other servers. How do you use AI to actually identify the location, the traceability, the sources of it, and remove it completely from the planet Earth, right, or the from existence? Is it possible to do that?
I'm not sure how well suited AI is for this particular problem. One thing that you can do with AI is generalize, right? So you don't have to say a particular word. You can talk about sentiment analysis. You can find places where there are negative mentions of you. But I don't think in the act of deleting itself, AI has any special advantages.
Okay.
Yep.
So a different kind of technology would have been applied in this case rather than AI per se, right? Okay. Still on the applications of AI by A.L. Chan. Okay, now earlier on we saw A.I. Chan, now became L. Chan, A.L. Chan. How can AI ML assist in winning an Olympic event or e-gaming competition? So that's the first part of the question. Is it considered an unfair advantage? He uses a very strong word, cheating or partially disadvantage, but is it an unfair advantage to be given for people who deploy it versus people who don't deploy it? Yeah. So I guess this relates to the sports analytics part that you can probably explain pre-competition, during and post-competition, widely applied in sports, but keen to hear your views and thoughts on that.
Yeah, so machine learning is already being used for sports. I gave you folks the example of sailing, and yes, sailing is an Olympic sport, right? In e-gaming, machine learning and AI is used. It's a cat and mouse game, right? So firstly, when you play a lot of these computer games, a lot of them are using AI trained models for the opponents, right? When you're playing in a single player game, it's probably an AI model. And then, okay, people use AI to cheat. So for example, you can get an aiming bot that aims for you in a shooting game. But it becomes a cat and mouse game, right? Because then what happens is the person making the game uses AI to detect AIs at the other end that you're playing against, and then kicks you off because you're using an AI. And then the person building the AI for the Autobot then tries to make the AI more human, so that, and so you kind of have this escalation, this arms race in terms of people building technologies where they use AI against AI. right? Um, and that prevents cheating. And there are, using machine learning to detect cheating is actually a very well-established field. So you use the problem against the problem. This is a very common pattern in machine learning. In fact, there is a specific model of machine learning called generative adversarial networks, where basically the way that you do it is you have two machine learning models that compete against one another. One that tries to build convincing fakes and one that tries to tell convincing fakes apart from reals. So, and that's actually led to some of the really interesting technologies and assistive technologies. Assistive, so you can ask an artist, or copying the style of an artist works that particular way.
Thank you. Very good answer there. We have two questions that can be linked together relating to data collection, data sample size, and so on. So by Elsa, as well as where's the other question? Elsa, and there's one more person talking about the accuracy of by WYN. Okay, so one asks about, is AI just rely heavily on just data collection, and within the data collection, what would constitute sufficient clean data or sufficient data being used to gain a certain accuracy when you run a certain model by WYN Lee? Okay, so maybe in a general context, you can explain about the importance of data, which you mentioned in your slides. I know that, but how do you address the question of increasing the accuracy as well as relying beyond just data? What else can it do besides just data collection? Thank you, Doctor.
Yeah. So yes, AI is very dependent on the amount of data, and it's fair to say that it is the thing that caused deep learning algorithms to succeed, was their ability to deal with like ridiculous amounts of data, right? Like literally when you train one of these word models, you're looking at every piece of text on the internet at once, right? But there is an effort to reduce the amount of data used to train machine learning models. So the idea is you teach a machine learning model to understand English, and then you only have to learn a little bit more about the problems in your particular domain. So this domain is called transfer learning or few-shot learning. So the idea here is that you reduce your mass. You learn about you learn from data that is not labeled or that is generic, and then you just tweak it a little bit for the data that you do have that's labeled, the small amount of data that you have labeled. How effective it is depends on the problem, and that's one of the things with machine learning. It's very hard to generalize. If I have this much data and this type of problem, how will I perform? And I gave the example of the stock market, for example, right? Like lots of data. There's no lack of data for stock markets, right? But you're never going to be able to get better than just over 50%. And if you do, the market's going to kind of wipe you out, right? Or the market will catch up with you and all of that kind of stuff. So it's very hard to give generalized guidance on performance of machine learning system until you look at the details of the domain.
Thank you, Doctor. Excellent. You spoken earlier about how AI need not operate on a large-scale infrastructure, right? Doesn't have to operate on very, very heavy kind of digital infrastructure. So the flip side of the question is from a person called Devendran again. What is your opinion then for edge computing, where running AI models in very, very small devices like modems, routers, and all that stuff? Probably in the field of nanotechnology, like Tony Stark's did for Iron Man, right, in the end game. So what are your thoughts on AI operating on very, very small devices, small microchips and all that?
There's been a lot of optimization on that, actually. So edge computing is a very large field that goes from big servers to tiny little IoT devices. We're seeing most of these smaller chips have AI models in them. It used to be like one of the projects I worked on at Google was recognizing steps from accelerometers. Now those algorithms are built into the chips, right? And they're super power efficient. So we are seeing it. Whenever you move to the edge, there's a trade-off between how frequently you update the model, how up-to-date the model is, and how close and how convenient and available it is, right? So in that example that I gave of machine learning algorithms for detecting walking, that's in the silicon now. It's going to be very hard to upgrade. Whereas if you're on the server and closer to the core of the network, you can be updating your model every 20 minutes, right? And so there's really a trade-off to be there. And edge computing is really about balancing bandwidth and the frequency with which you want to update the model. But yeah, I'm seeing a lot of progress there, and you can go very small. Simple machine learning models are not very big. Deep learning models are huge, but people are working on crunching them down into much smaller sizes. And there are machine learning models specifically designed for ultra-low processes.
Thank you, Doctor. And there's a question back to the applications of AI, where Muhammad Fazli mentioned about the lack of AI deployment, or so it seems, in the construction sector. So he noted that a lot of it mainly lies in the B2C segment, right? But how about the B2B side of things, such as construction? So what are your thoughts on how AI ML could be deployed in construction from upstream, downstream, and all that perspectives?
Yeah. So I wish I knew a lot more about construction, but my understanding, speaking to people who've worked in construction, is that it's a gigantic, in practice, for large projects, it's a gigantic logistics exercise where you're trying to optimize timing, you're trying to characterize, when things should arrive. I think the construction, the optimization problems, the logistics problems, and using machine learning to optimize the logistics problems is one potential model. The craziest thing that I've seen is there's a company called Boston Dynamics, and they make a robot that they send around the construction site to build the 3D model of the construction site, so that at any time you can inspect the state of the system, right? There's also a lot of work on post-construction, right? How do we build smart buildings? How do we have buildings that, kind of detect when there's construction focus? So it's not just about the construction process, it's about, and especially here in the United States, there's just, the incident in Florida where a major building collapsed. People are really thinking about how do you build intelligence into the building itself. So yeah, there are quite a few applications there, but probably construction is probably one of those areas that is very traditional in some ways, but we are already starting to see applications.
So when it comes to construction, when it comes to engineering, when it comes to STEM-related, STEM, right? STEM-related discipline versus the humanities side of things, humanities like geography, history, the arts, basically, how would you address the question of the traceability of it? Because a question by Raymond Rasfuldi talks about the lack of external AI or some AI algorithm, right? Would it limit the sectors such as engineering, STEM related, as opposed to, for example, the arts, the performing arts, the arts, humanities style of things, STEM versus humanities? Would the lack of explainable AI be more pervasive in one over the other, or would it still be the same, you think?
Yep. So when it comes to STEM, it really just depends on the domain, right? In some domains, explainability is very important, right? Why did this particular person not get a credit card? You need to be able to defend that decision, right? And that's like putting aside STEM and arts. Finance is one area where explainability is very important, right? And there's questions of fairness there, right? In STEM, I think the bar is higher in terms of explainability generally, right? Whereas in the arts, because it's a collaborative, the way AI is being used in the arts is as a collaborative tool, and it's already kind of an exploratory device, explainability is not quite as important, right? What really matters is like the end result. And so I think for that reason, there's a lower bar in the arts and its application to the arts.
Thank you so much for that. And there's a question from Raymond. A question from Shazvina. I think Doctor did mention about how agriculture could adopt or deploy AI and hence elevate the livelihood of farmers. But perhaps you could give a short answer to that to Shazvina, please.
Yeah. So this is one very, very active area, right? Farming has been aggressive about the use of technology for a long time. Whether it's autonomous. So let me give some examples. Autonomous vehicles that kind of crop the field, right? So instead of a farmer having to drive their tractor all over the field, you can make that autonomous. There's a new industry that's picking up called vertical farming. So in urban centers, you have walls of sensors, and they're using AI to fine tune to maximize growth rates and to choose when the right time. So they use a camera, they look at it, they pick the right time to harvest. There are People are now asking for organic products. So people are building robots that use AI to look on the ground for weeds and to extract weeds. So really, this is a very, I was going to say this is a very fertile area, but maybe that's an unintended pun. Yeah, there's a lot of stuff in the agriculture space. And frankly, the agriculture space, because it's all about efficiency, has been very, very well served in that regards. I do have one more example in construction, right? So people are now starting to use autonomous vehicles in construction applications that kind of go around, push the concrete around, push the things around. And often because there are safety concerns in mines, construction sites, having autonomous vehicles actually improves human safety. And so that's another area that's really growing.
Thank you, Dr. Waleed. We have one last question to answer. For those of you who would like to get in touch with Dr. Waleed, he has given his email earlier on, and I hope the organizer will put up his email address in the chat box. At the same time, someone was asking earlier on in the earlier part of Q&A whether they could get hold of Dr. Waleed's deck. I leave it to him and the organizer to make it available or not to the audience. Yeah. But one last question that will basically wrap up the whole exciting session. You've essentially did a marathon, a sprint, Dr. Waleed. You've got like 25 questions plus one to be answered. That's like a record for a 30-minute discussion. But essentially, so kudos to you. So let me, rephrase Mr. Nadir's, Brother Nadir's question. Yeah. So we spoke about how AI and ML could replace or elevate or augment the labor force earlier on, right? Rising from a question. Then he went on to ask, do you think AI ML will endanger the human being? Right, so to put it in a less damning way, I would like to bring across the question to Dr. Waleed. Yeah, you've spoken about the benefits of AI, you've spoken about the dangers of AI, okay, the risks associated with AI, and fairly and surely you list out what are the caveats and your candid, your honest view about the limitations of AI. So you have both sides of a coin that you presented. So my final question to you on behalf of the audience, for you to wrap up this whole exciting session that you conducted, is that net, right? At the end of the day, would AI be deployed effectively to help the nation, to help the sectors, to help the people? And what sort of outlook do you have when it comes to AI deployment to help humanity become better and work better without the costs, without taking on too much of the cost associated with it? So maybe you can summarize it and we can end the session, inshallah, with your good knowledge being shared with others. I hope everybody has benefited from it. Then we'll pass back to Ina. Thank you so much, Doctor. All yours.
Yeah. So first of all, thank you again to the organizers for inviting me. I've had such a fun time here. I've really enjoyed the questions and answering the great questions you folks have been asking. AI is a very, very powerful technology. There are some people who claim it is, beyond the scale of the Industrial Revolution, right? And I can understand why, right? Like the unique thing about us as humans is our ability to think, recognize patterns, process language. These are things that historically have been unique to us. Any powerful technology can be used to help humanity. It can also be used to disadvantage humanity. But overall, if you look at the arc of history and the way, generally, with some exceptions, right, technology has helped to make the world a better place. It has helped to make the world more efficient. The mobile revolution has enabled people who previously didn't have access to education to be able to have access to education. The Khan Academy has enabled people who previously it was very hard to have access to education to get it for free. Right? So I think the challenge for us as people who are in positions of influence and as Muslims is to ensure that AI is used for its best possible applications and not for its worst possible applications. And I think that that's really something that all of us have a professional responsibility to do. And when we see something going wrong within our company where it's something that's not quite right, that we really think carefully about how we raise our concerns about is AI being used correctly? And again, I'm just so grateful to all of you for spending some time with you to kind of discuss these issues and to learn from you about the challenges that you're facing.
Thank you so much, Dr. Waleed. I've learned a lot so much from you, and of course the audience too, I'm sure. So thank you for gracing and presenting your thoughts and ideas, as well as views on AI and ML. So thank you, the organizer, for organizing this excellent session. Not easy to get, Dr. Waleed. So we are very grateful on behalf of the audience. We're very grateful that you're willing to share your time and knowledge with us. So over to you, Ina. Thank you so much, Dr. Waleed, and members of the audience.
Thank you again.
Thank you all. And that's all the time we have for today's session. Now, we truly hope that you have gained valuable input and will be beneficial to you. Thank you again to everyone for being here today and making this webinar successful. Now, please spare some time to complete the survey form we've prepared for you at the end of the session. Please also follow us on Facebook, Instagram, LinkedIn, Twitter, and YouTube for regular news and happenings. Now, on behalf of WIEF Foundation, thank you for joining us today. Stay safe and have a great day ahead.